November 2nd, 2024. Falcon 9 launches Haven demo into orbit. This fully operational space station prototype was built in just 2 years by a team of only 200 engineers at Vast Space. How did they move this fast when NASA's traditional modules take 5 to 10 years? The secret lies in SpaceX's proven method: rapid iteration, complete in-house manufacturing, and cutting through bureaucratic delays. This mission tests every critical system needed for Haven 1, the first commercial space station set for May 2026. Let's dive right in. Here's what most people don't understand about space station development. When NASA builds modules for the ISS, they follow a process refined over decades: endless reviews, committee approvals, contractor negotiations, and layer after layer of bureaucratic oversight. The result? 5 to 10 years from blueprint to launch, sometimes longer. Vast Space threw that entire playbook out the window. So what did they do instead that cut development time by more than half? The answer starts in Long Beach, California, at Vast's facility, where something revolutionary was happening. Instead of farming out components to dozens of contractors across the country, Vast made a critical decision: build everything under one roof. Manufacturing, integration, testing, all happening in the same building with the same team. No waiting on suppliers, no coordination delays between different companies. Just direct control and real-time feedback. When an engineer spotted a problem, they could walk across the floor and fix it that same day. How much time does that save compared to traditional aerospace contracts? But speed alone isn't the breakthrough here. Vast borrowed directly from SpaceX's operational DNA: test, fail, learn, rebuild. Traditional aerospace lives in fear of failure. Every mistake triggers investigations, reviews, and schedule delays. Vast embraced a different philosophy. They built prototypes knowing some would fail. They tested systems expecting to find flaws. Each failure taught them something that made the next version better. This iterative approach, moving fast through multiple design cycles, proved far more effective than trying to achieve perfection on paper before ever building hardware. Which method do you think produces better results? The team behind this achievement? Just 200 people. Compare that to the thousands employed by legacy space programs, each adding another layer of management, another approval process, another delay. Vast's lean structure meant faster decisions, tighter alignment, and everyone pulling in the same direction. When you have fewer people, every person matters more. There's no room for bureaucracy when you're racing to prove a concept that could reshape humanity's future in orbit. Can a small, focused team really outperform massive aerospace corporations? Launch day arrived on November 2nd. Falcon 9 roared to life, carrying Haven demo toward orbit. Stage separation confirmed. The spacecraft now alone, climbing into the void. Then came that moment every mission team dreads: the waiting. Ground control staring at screens, hoping for that first signal. Will the spacecraft wake up? Did it survive the violence of launch? These aren't theoretical concerns. Space is brutal, and hardware that works perfectly on Earth can fail catastrophically when exposed to vacuum, radiation, and extreme temperature swings. Then telemetry started flowing, data streaming back to Earth like a digital heartbeat. Haven demo was alive. Solar arrays deployed flawlessly, unfurling like mechanical wings to drink in sunlight. Power generation exceeded consumption, a positive energy balance, the most critical indicator of mission success. Communication links locked solid with ground stations. The control room erupted. 2 years of relentless work, countless late nights, and calculated risks had just paid off. But what exactly was Haven demo testing up there? This isn't just a satellite. It's a complete space station prototype minus the life support systems for humans. Every technology Haven 1 needs to keep astronauts alive is being validated right now in the actual space environment. Radiation-hardened computers, processing commands, propulsion systems firing to maintain orbit, navigation sensors tracking position with pinpoint accuracy, communications arrays linking to ground control and Starlink satellites, power systems cycling through day-night transitions, software managing hundreds of autonomous functions. And here's the crucial part. All of this has to work flawlessly for 6 months straight. Why 6 months? Because that's the minimum duration needed to prove these systems can support Haven 1's 3-year operational life. Every day in orbit, Haven Demo generates data. Engineers on the ground analyze performance metrics, identify issues, and refine designs for Haven 1. This is real-world testing you simply cannot replicate in ground facilities. You can't fake the radiation environment. You can't perfectly simulate thermal cycles between sunlight and shadow. You can't reproduce the true vacuum of space. Haven Demo gives VAST something priceless: confidence that when they launch Haven 1 with astronauts aboard, those systems will work. What would happen if they skipped this step and went straight to human missions? Now let's talk about Haven 1 itself, because that's where this story gets really interesting. While Haven Demo orbits overhead, the actual station is taking shape in California. As of October 2024, Haven 1's primary structure passed pressure and load acceptance testing. That means the hull can withstand the stress of launch and maintain air pressure in the vacuum of space. The signature dome window has been installed, a 1.2-meter portal that will give astronauts breathtaking views of Earth. Final weld inspections are underway, and the module is moving into the clean room for full integration. But Haven 1 isn't heading straight to the launch pad. First stop, NASA's Neil Armstrong Test Facility in Ohio, where it will face a gauntlet of environmental tests designed to destroy it. Acoustic chambers will blast it with sound levels matching rocket launch. Shaker tables will vibrate it until components either hold or break. Thermal vacuum chambers will cycle it through temperature extremes from -150 to +150 degrees Celsius. Radiation exposure will simulate years in orbit. Only if Haven 1 survives this torture will it earn approval to carry humans. Does this seem extreme? Consider what happens if a critical system fails with astronauts aboard. Target launch date, May 2026, aboard Falcon 9. Once in orbit, Haven 1 becomes the world's first fully commercial space station. Not government-funded, not NASA-operated, entirely private. The station measures 4.4 meters in diameter, with 45 cubic meters of habitable volume, about the size of a city bus. That's roughly 1/8 the International Space Station's interior space. 4 sleeping berths, a communal area with that massive window, Haven 1 lab for microgravity research, storage lockers, a docking port for Crew Dragon. It's compact, efficient, and laser-focused on proving the concept works. VAST CEO Max Hayat made the mission clear. This isn't a space hotel. Haven 1 exists to demonstrate that astronauts can rest better, communicate better, and work better in a well-designed private station. 3 years in orbit, up to 4 crewed missions, each carrying 4 astronauts for 10 to 14 days. The inaugural mission, VAST 1, targets late June 2026. Crew Dragon will dock with Haven 1 and remain attached throughout the stay, effectively serving as a second module and backup habitat. Why keep Dragon attached instead of sending it home? Here's where the SpaceX partnership becomes critical. VAST builds the destination. SpaceX provides everything else. Falcon 9 launches the station. Crew Dragon transports astronauts. Starlink delivers high-speed internet for communications. SpaceX handles astronaut training, including emergency protocols and docking procedures. Power systems integrate across both spacecraft. It's a complete end-to-end solution that no other company on Earth can provide. VAST couldn't move this fast without SpaceX, and SpaceX benefits from having another major customer for Crew Dragon missions. Who else wins from this arrangement? But Haven 1 is just the beginning, the proof of concept that earns credibility. The real goal is Haven 2, a modular, expandable station designed to replace the ISS after its retirement around 2030. If VAST secures a NASA commercial LEO destinations contract in 2026, the first Haven 2 module launches aboard Falcon Heavy by 2028. This module will be 5 meters longer than Haven 1 with nearly double the internal volume. Then 3 more modules follow over the next 2 years, all built to the same cost-effective design. By 2032, Haven 2 reaches full operational capability with 8 total modules, a 7-meter diameter core, and that massive 12.5-meter cupola window, one of the largest ever flown in space. Haven 2 isn't just bigger. It's designed for serious orbital operations. A robotic arm for payload handling, berthing ports for visiting spacecraft, an external payload airlock, a dedicated airlock for spacewalks. The Haven 2 lab with advanced facilities for microgravity research and in-space manufacturing. Greater volume, more power, larger payloads. Everything needed to serve as NASA's primary platform in low Earth orbit after the ISS is gone. But here's the challenge. VAST isn't alone in this race. Axiom Space, Blue Origin, and Northrop Grumman are all developing competing concepts. NASA will choose one, maybe two companies to fund. The stakes couldn't be higher. This is the new space economy taking shape right now. NASA transitions from builder to customer. Private companies compete to provide better, faster, cheaper solutions. And companies like VAST, born from SpaceX's culture of rapid innovation, are proving they can deliver what once seemed impossible. A functional space station prototype built in 2 years, a commercial outpost launching in 2026, a modular successor to the ISS by 2032. So what have we just witnessed here? A 200-person company just accomplished in 2 years what traditional aerospace said couldn't be done. Haven Demo is orbiting Earth right now, validating every system needed for human spaceflight. Haven 1 is being assembled in California, heading for launch in May 2026. And Haven 2, the real ISS replacement, could be operational by 2032. This isn't speculation anymore. This is happening. The old model is dying. NASA's approach of spending a decade and billions of dollars to build a single module can't compete with VAST's speed and efficiency. When you cut through bureaucracy, manufacture in-house, and embrace rapid iteration, you move faster than anyone thought possible. SpaceX proved this with rockets. VAST is proving it with space stations. And they're doing it right now while legacy aerospace companies are still stuck in committee meetings. But here's what matters most. This changes everything for humanity's future in orbit. When the ISS retires in 2030, we won't have a gap. We'll have multiple commercial stations competing to provide better services at lower costs. Research that once required government funding will become accessible to universities, private companies, even individuals. The barrier to space is crashing down, and VAST just kicked the door wide open. What do you think? Can a private company really replace the ISS? Will Haven 1's first crew launch on schedule? Drop your thoughts in the comments below. If this story amazed you, smash that like button and share this video with anyone who still thinks space is only for governments. Subscribe to Space Update 24 hours and hit the notification bell so you don't miss what happens when Haven 1 launches next year. We're living through history right now. Let's watch it together.